Good morning to all of you. First of all, I want to introduce myself. Myself Ankit Acharya, working as an assistant professor in Hasmukh Goswami College of Engineering. And today my content is GTU question paper solution of the subject of vector calculus and linear algebra of December 2013. So this is latest question paper which was asked in the last year December. So here is the content. Vector calculus and linear algebra is the subject. GTU paper solution December 2013. Question 1a. First question, first part. Show that the differential form under the integral of I, that is equal to integration from 0 minus 1 1 to 2 4 0 e raised to x minus y plus z square into dx minus dy plus 2z dz is exact in space and evaluate the integral. So first of all, what is the definition of exact differential equation? Exact, what is the meaning of exact? That means equation, the derivative of that equation is itself, that is the exact differential equation. That is, see here, d of e raised to x minus y plus z square, that is equal to e raised to x minus y plus z square into when you take derivative of this function, so into the derivative of x, that is dx minus dy plus z square, that is 2z dz. So now you can say that this form is an exact. Okay, now evaluate the integral. Integration is from 0 minus 1 1 to 2 4 0 e raised to x minus y plus z square into dx minus dy plus 2z dz, that is equal to, in the bracket, right? So this is exact, so you can say that the integration of this part, that is exactly e raised to x minus y plus z square, because of the derivative of e raised to x minus y plus z square, that is equal to this term, right? So in other words, you can say that integration of this part, that is equal to exactly the e raised to x minus y plus z square, right? So we know that derivative and inverse integration are inverse of each other. Okay, so that's why the integration of e raised to x minus y plus z square into dx minus dy plus 2z dz, that is equal to e raised to x minus y plus z square 0. Now integration is from 0 minus 1 1 to 2 4 0. So first of all, put 2 4 0 instead of x, y and z in this equation, in this function. So you will get, when you put 2 4 0 in this equation, e raised to 2 minus 4, right, plus 0. So you will get e raised to 2 minus 4, and when you put minus, when you put instead of x, y, z, you put 0 minus 1 1, you will get e raised to 0 plus 1 plus 1, so that is e raised to 2. So e raised to minus 2 minus e raised to 2. Okay, so this is the integration, this is the answer. Integration, that is equal to e raised to 1 upon e square minus e square. So basically this is 1 minus e raised to 4 upon e square. Okay, so here is the complete the solution. Next question. Question 1a, second part. A parametric representation of the surface is given. Identify and sketch the surface. So here is the equation r of uv, that is a cos ui plus a sin uj plus vk, where vary in the rectangle r is from 0 to 2 pi and v is from minus 1 to 1. So here take x is equal to a cos u, y is equal to a sin u, and z is equal to v. Okay, so for any point x y z on the surface we have x square plus y square. Let's see x square. What is x square? X square plus y square, that is equal to a square cos square u plus a square sin square u, that is equal to a square. So this is a circular cylinder with z axis as axis, radius a and height 2, because see what is v is from -1 to 1, right, and r is from 0 to 2 pi. So this is a circular cylinder with z axis as axis, radius a and height 2. The curve v is equal to constant are parallel circles and the u is equal to constant are vertical straight lines. Okay, so here the complete the solution of this part, question 1a, second part. Next question, question 1b. For which values of a will be following system have two solution? First is exactly one solution. Question is exactly one solution, then infinitely many solution. Okay, here is a question. So x plus 2y minus 3z, this is the first equation. X plus 2y minus 3z is equal to 4, and 3x minus y plus 5z is equal to 2, and this is the last equation, that is 4x plus y plus a square minus 14 into z, that is equal to a plus 2. So the matrix equation of the given matrix is ax is equal to b, right? What is a? A is a matrix which is coming from these three equations. The first row is exactly the coefficient of x, y, z in the first equation. You can see what is our first row, 1, 2, minus 3. So here is the first equation, x plus 2y minus 3z. So this is exactly the coefficient of x, y, z in the first equation, that is 1, 2, minus 3. Similarly, you can see the second row is coming from the second equation, that is 3, minus 1, 5. Exactly the coefficient of x, y, z is 3, minus 1, 5, right? So we are arranging this coefficients in matrix form using this method. Okay, so now coefficient of x, y and z in the third equation, that is 4, 1, and this is also a coefficient, that is a square minus 14. So this is a square minus 14 x, y, z, that is equal to 4, 2, a plus 2. Okay, b, that is this part, right hand side part, that is 4, here 2, and this is a plus 2. So 4, 2, a plus 2. So now the augmented matrix A gem B, that is 1, 2, minus 3, 3, minus 1, 5, and then 4, 1, a square minus 14, and then 4, 2, a plus 2. Okay, now what is the first process? What we have to do now? Next, we have to convert this matrix into a row echelon form, right, or reduced row echelon form. Now what is the meaning of row echelon form or reduced row echelon form? That I want to explain. First of all, a matrix which satisfied the three conditions, it's called row echelon form matrix. First of all, try to understand what is the meaning of leading entry. What is the meaning of leading entry? Yeah, you take any row, right, and when we are going from left to right, the first non-zero element is called leading entry, or sometimes we call pivot, right? Now the first condition is below that pivot or below that leading entry, in that column all the elements should be 0. That is the first condition, right? Again I repeat that below that leading entry, in the first column, in that column in which we have leading entry, below that leading entry all the element should be 0, right? That is the first condition. The second condition is if there is any zero row, it should be the bottom of the matrix in that matrix, right? So if there is any zero row, it should be the bottom of the matrix. And the third condition is whenever we are going from above to below in that matrix, our leading entry is going from left to right, right? Whenever we are going from above to below, our leading entry is going from left to right. So if any matrix satisfied these three conditions, we can say that the given matrix is in row echelon form. Now next is reduced row echelon form. Now when we say that a matrix is in reduced row echelon form, first of all it should be the satisfied these three conditions, right? First of all it should be the satisfied these three conditions. That means what? It should be the row echelon form matrix, right? Now to become a reduced row echelon form, we have to add two more conditions, and from that two more conditions, the first condition is the leading entry must be 1. The leading entry must be 1. And the second condition, if there is any leading entry in any column, in that column except the leading entry, all the elements should be 0. So not only the below elements, not only the 0 element, but if there is any leading entry in that column above the ઉપરના એલિમેન્ટ, બરાબર, સાદી ભાષામાં કહીએ તો ઉપરના એલિમેન્ટ. સો અબાઉ ફ્રોમ ધેટ એલિમેન્ટ all the element should be 0. Okay, so in that column except the leading entry, all the element should be 0. So this three, if these two conditions are added, then we can say that a matrix is in reduced row echelon form. Okay, so let's see how to solve this example. The question is here that these three equations, in which condition for A, that in which conditions for A, which values of A will be the following system have to solution, exactly one solution or infinitely many solutions, right, or no solutions. So our question is, so first of all we are converting this matrix into a row echelon form, and let's see how to solve this matrix into a row echelon form. So 1 2 minus 3 4, 3 minus 1 5 2, 4 1 a square minus 14 and a plus 2. So I want to make 0 in this element except right. So this is our leading entry, this 1 is my leading entry. I want 0 here in the first column, below that leading entry I want 0. So what we have to do, we are multiplying first row with minus 3 and add into the second row. So this element becomes 0, and with the same process we are multiplying first row with minus 4 and add into the third row. So this element becomes 0, right? So let's see how changes in this matrix, how make change. So here is the process. Write down in this manner, R12 minus 3, that means we are multiplying first row, we are multiplying first row with minus 3 and add into the second row, and we are multiplying first row with minus 4 and add into the third row. So here is the first row, 1 2 minus 3 4, right, 0 minus 7 14 minus 10. How? See, 3 minus 3 0, then minus 1 minus 2 into 3, right, minus 1 plus 2 into minus 3, so that is minus 1 minus 6, that is minus 7. Now next is 5 minus 3, so 5 plus 9, so that is 14. And next is 2 minus 4 into 3, so that is 2 minus 12, so you will get minus 10, correct. Now next is, see, 4 minus 4, that is 0, 1 minus 2 into 4, so that is minus 7, 1 minus minus 8, 1 minus 8, so that is minus 7. Then a square minus 14 minus 3 into 4, correct. So you will get a square minus 14 minus 12, so that's why you will get a square minus 26, okay, or a square minus 14, sorry, a square minus 14 minus 3 into minus 3, sorry, 4 into minus 3, so you will get a square minus 14 plus 12, a square minus 14 plus 12, so you will get a square minus 2, okay. So here a square minus 2, and then a plus 2 minus 4 into 4, okay. So a plus 2 minus 16, so you will get a minus 14. Clear? Now see, is this matrix is in row echelon form? No, because see, this is leading entry, below that leading entry we have 0 here. Now this is our leading in second row. Now next is our second row, this is our leading entry, below that leading entry we don't have 0 here, right? So we have to make 0 here, so that's why we are multiplying the second row and with minus 1 and add into the third row, right? So that's why we make 0 here. So that's why this is our process, we are multiplying second row with minus 1 and add into the third row. So the first row is as it is 1 2 minus 3 4, the second row is also as it is 0 minus 7 14 minus 10, the third row become 0 and 0 minus 7 minus 7, so that is 0, a square minus 2 minus 14, so you will get a square minus 16, a minus 14 plus 10, so that is a minus 4. Okay, now see, this matrix is now row echelon form. Okay, this is our leading entry, below that leading entry we have 0, this is our leading entry, below that leading entry we have 0 here, and this matrix we don't have any 0 row, so that condition need not to be checked. Leading entry definitely is going from left to right whenever we are going from above to below, right? So you can see this is our leading entry in second row, this is our leading entry in third row, this is our leading entry, so definitely leading entry is going from left to right. Okay, so this is our matrix 1 2 minus 3 0 minus 7 14 0 0 a square minus 16. Now the question is for which values of a the given system of equations have no solution, exact solution and infinitely many solutions. Okay, now try to understand. See, this is a square minus 16. Okay, if suppose a square minus 16 is equal to 0 and a minus 4 is not equal to 0, so what equations we have? 0 into x plus 0 into y plus 0 into z, that is equal to non-zero element. That is not possible. Okay, that is not possible. So the condition is